Definition of an inverse variation. If y equals k divided by x for some non-zero constant k, we say that y varies inversely as x, or that y is inversely proportional to x. We call k the variation constant or the constant of proportionality. The equation y equals k divided by x is called an inverse variation equation. So once again, in this case, our keyword is inverse. What type of variation? It's an inverse variation equation. So if y equals, so we have y equals, our constant in this case, k once again, is on the top. The divided by our variable, in this case, the x. So once again, it's inverse variation because it's division. So if y equals k divided by x for some non-zero constant k, we say that y varies, how does it vary? Inversely, right? Meaning it's a division as x, or we can also say that y is inversely proportional to x. So now be careful in just using the word proportional. You have to use inversely tied to that word proportional, otherwise it could be a multiplication. So since it's inversely proportional to x, we call k the variation constant or constant of proportionality. So once again, the equation y equals k divided by x, once again notice the x is the division, right? It's what's being divided, or what you're dividing as a variable or expression, is called an inverse variation equation. So once again, keyword inverse variation. So for inverse variation, keep in mind the word proportional and be careful on how you use it, right? Because it could mean multiplication or division. You got to tie the right words with that one if you only use that proportional word. You got to say it's inversely proportional. So inversely proportional meaning it's a division. In other words, y equals k divided by x format because we're dividing. Okay, so let's try out a bit more of an explanation. So to find and use an inverse variation model, assume that the quantity p varies inversely as a quantity t. 1. Substitute the values of the data point into the equation p equals k divided by t. Then solve for k. 2. Substitute the value of k into the equation p equals k divided by t. And 3. Use the equation to make estimates for p or t. So once again, keyword inverse variation. Agreed? So inverse is the main keyword. You can also use proportional, but be careful. Always remember that inverse implies, in this case, division. So it's an inverse variation equation. Our equation, y equals k divided by x, is our general format. Once again, it's a division, right? So notice that all of our examples in this case are stated as they're inversely related. So let's be cautious in that case and remember that it's a division. Okay, so A, we have h varies, and how does it vary? Inversely as d. So the keyword inverse, h equals k divided by d. Agreed? And let's just restate over here on the right to make it easier and more cleanly. H equals k divided by d would be our final equation, since we don't know what the k is or how to get the k value in this case. So for our next one, B, y varies inversely as x plus 6. So x plus 6 is the variable or the expression in this case that goes underneath the denominator, in other words. So let's show it over here in a clean area. It makes it easier to visualize. B, for B we have y equals because it comes first. And how is it related? It's inversely related, right? Or inverse variation, meaning division. K divided by x plus 6 in this case. Remember, put x plus 6 in parentheses, makes it easier to visualize. Okay, so now let's go for the next case, C. For C, it says the z varies inversely as r squared. So what came first is the z, right? So z equals. And what's being divided? Divided by r squared would be therefore our k on top. So therefore it is r squared is going on the bottom. So our k is on top. Let's realize this constant is on the top. And once again our z on the left side because it came first. And our r squared came second on our statement. So it's r squared. It's what's dividing the k. Okay, so let's just once again copy it over here on the right side cleanly. So z equals k divided by r squared, just a restatement of my formula so far. And now we have a special case scenario where we know a coordinate point or two coordinate values, in other words, for the same location. Z equals our pi over 9 was given when and r equals 3. So z getting replaced for the z up on our equation. And the r, we can substitute it for our r as well to find what k is. So let's replace them and find what the k value is. Agreed? So we have pi over 9 for our z value and 3 for our r value. Now 3 squared. 3 times 3 is 9. Agreed? So we have pi over 9 equals k over 9. And finally, let's solve for k by multiplying the k since it's dividing currently. To get rid of the k, pardon me, not the k, to get rid of the 9 from the k, I should say, we multiply times 9 here and times 9 on the other side as well. 9s cancel out, meaning it gives us a 1 when we're multiplying or dividing. Therefore, pi equals k. And finally, we can substitute it into our final equation, or what we originally came up with, right? The equation up close to the top for c. Z equals k over r squared. Remember our k, we just found out that k is pi. So there is our pi value. So there is our final equation. So from here on, if we knew another specific case, like let's say we knew that r equals 15, then we will substitute 15 for the r and find out what the z value is. Or if we knew z was something like 100, we would plug in 100 and solve for the r. Agreed? Otherwise, this is as far as we can get for this particular case, at least. So, once again, inverse variation implies we're dividing, okay? Constant on the top.